you missed class today, or if you just want a refresher, that's what this video is for. It's just a recap of the same examples that were done in class. So today we were looking at solving systems by substitution. We started out with, well, what if we already know what one of the values in the system is, but we don't know what the second value is? So for example, in number 1 here, we know that x equals 5. In that case, I would take this 5 and I would substitute it in for the x in the second equation. That way, I can solve for the y in that equation, because if it's solving the system, then x is the same in both equations. So 2 times 5 is 10, minus 3y equals 25. And then to solve the equation, I need to subtract the 10 from each side. So negative 3y equals 15, and divide both sides by negative 3. And we have y equals negative 5. But we're also going to get in the habit of, when we're solving a system, we're not just going to say x equals 5, y equals negative 5. We're going to write our answer as an ordered pair, because solutions to systems represent a point on a graph, because these are lines, and if we graph the lines on the graph, then we have a point of intersection. So our solution is that point of intersection, 5, negative 5. Let's take a look at the second one. In the second system, we know that y is negative 3. So I'm going to take this y, this negative 3, and I'm going to substitute it for y in the second equation. So we're going to have negative 4x plus 6 times negative 3 equals 30. Simplify the left-hand side of the equation. 6 times negative 3 is negative 18 equals 30. Add the 18 to both sides. And we have negative 4x equals, let's write that a little clearer, 48. Divide both sides by negative 4, and x equals negative 12. The solution then to this system is negative 12, and the y is negative 3. Remember, ordered pairs are always written x first, y second, just like in the alphabet, x first, y second. The next example, if you took the time to watch the video like you should have before class this week, was an example of, we had a system, we wrote the equations for the 2 lines, and then we solved that system. Well, because both equations were equal to y, we're able to take the expression that y equals in one equation and set it equal to the expression of the other. So I'm taking this 8x plus 4 and I'm substituting it for the y in the second equation, because y equals that expression. So my equation that I'm going to start with is 8x plus 4 equals negative 6x minus 10. And then I'm going to balance my equation, and I'm going to get my variable on one side of the equation. Now, I like to keep the variable term positive, if at all possible, so I'm going to start by adding 6x to each side of my equation. So 8x plus 6x is 14x plus 4, and on the other side of my equation, I'm left with negative 10. Subtract 4 from each side, and I now have 14x equals negative 14. Divide both sides by 14, and x equals negative 1. But I'm not finished. In order to solve a system, I also need to know what y equals. So I'm going to take this negative 1, and I can substitute it in for x in either equation. I'm just going to go ahead and substitute it for x in the second equation. So y equals negative 6 times negative 1, subtract 10. And simplify that right-hand side of the equation. So we have 6, subtract 10, because a negative times a negative is positive, equals negative 4. And then, because this is representing a point on a graph, my solution is negative 1, 4. Now, a system isn't always two equations that are y equals. It might be one equation is y equals, and one equation is what we call standard form. Still set up pretty nicely for a substitution, because I know what y equals. I'm going to take this negative x plus 3, and I'm going to substitute it for the y. So be careful that you're substituting for the correct variable. So y equals negative x plus 3, therefore negative x plus 3 goes in place of the y. So we're going to have 3 parentheses, replace y with the expression negative x plus 3 plus 5x equals negative 1. Then I'm going to distribute 3. So I have negative 3x plus 3, or plus 9, excuse me, plus 5x equals negative 1. And then if I look at this equation, when I go to balance it, my x terms are on the same side of the equation. So I'm going to combine them. I'm going to add them together. Negative 3x plus 5x is 2x. Plus 9 equals negative 1. Subtract 9 from each side, and we have 2x equals negative 10. Divide both sides by 2, and x equals negative 5. Now I still have to find y, and it doesn't matter which equation I substitute it into. However, if I substitute it into the first equation, I substitute it for x in the first equation, I'll get y, because all I'll have to do is simplify the right-hand side of the equation. So I have y equals a negative, and then I'm going to put parentheses for the x. And then inside those parentheses is negative 5, because x is negative 5, plus 3. So now we need to simplify this negative 5, or in other words, what's the opposite of negative 5? Because that's really what negative is opposite of. So that's a positive 5 plus 3 is 8. And our solution is negative 5, 8. And one more example that we may or may not have gotten to in class, but I'm going to include in this video, is we don't always have to substitute for the y. We can substitute for the x. So in this case, I have x equals 6y minus 7. So the 6y minus 7 is equal to the x, so that's going to go in place of x in my second equation. So I have 4 parentheses 6y minus 7, close the parentheses, plus y equals negative 3. So what I've done is I've replaced x with the 6y minus 7, because that's the expression equal to the x. And then we can distribute 4. So we have 24y minus 28 plus y equals negative 3. So 24 plus y, again, trying to balance this equation, and the y terms are on the same side, so I'm going to combine these terms, and keep in mind that a plus y is the same as saying plus 1y, so that's going to be 25y minus 28 equals negative 3. Add the 28 to both sides, and we have 25y equals 25. Divide both sides by 25. And y equals 1. Now that I found y, I need to find x. So I'm going to take this y and I'm going to substitute it in the first equation because that's an x equals equation. So x equals 6 times 1 minus 7. So 6 times 1 is 6. Subtract 7 is negative 1. So the solution, now be careful here, we found y first and x second, so make sure you're paying attention to writing the ordered pair. X is first. Negative 1, 1 is our solution or our ordered pair to this system. If you still have questions after watching this video and watching these examples, please reach out to me and I will assist you.